Good morning, children. Mrs. Rikta Das, PGT Chemistry, KV, Army Area, Pune. I have taught you before the IUPAC nomenclature. All the function group, I have completed that. I am just going to give you now some examples. Just see whether you are able to do that or not. And this one is in continuation with what was taught to you before. I will just list down some 4 examples of organic compound and just see whether you are able to do it or not. Let us just try out the 3 examples. I have written here 3 organic compounds, see whether you are able to solve it or not. If you have completed, just try to check the first one. There are 5 carbon atoms and hence for the carboxylic acid, I have told you before the name goes as alkanoic acid. So, there are 5 carbon atoms, so it goes as pentanoic acid. In the 4th position, I have got an hydroxyl group. I cannot use the word all here. So, this part this part here it goes as 4 dash hydroxy pentanoic acid. You have got carboxylic acid as well as the aldehyde group. Carboxylic acid has been given more preference and hence here the name goes as, once again you see I have taken a pentanoic acid. Now, 4th position I have got an aldehyde group. Now, should I go for the word al? I cannot go for the word al because aldehydes are not given preference when there is a carboxylic group present. So, here in the 4th position I am going to use the word here as formyl. I am coming to the 3rd one. Here once again you can see here I have taken once again the carboxylic acid as pentanoic acid. Here in the 4th position I have got a ketonic part. Ketones are generally written with -one, but in this case I cannot use the word as -one because carboxylic acid is given preference. Now, the keto part goes as oxo. So, 4th position oxo. I hope it is clear to everyone. One last example, as I told you that I am going to give you some 4 examples, just try to do this one. I am telling this is one of the acid which you would have used in the titration in the 11th standard. 11th standard you had acid based titration. I have written here a compound. This compound is oxalic acid. If I split up the compound, this is how the compound structure. What name can I give it to this? There are 2 carboxylic acid. So, it is oic acid. There are 2 of them and hence the word goes as dioic acid. As it was told in the first part when I was teaching you the IUPAC nomenclature, whenever the word di comes there should be 2 numbers. So, this is the first carbon, this is the second carbon atom. So, 1, 2 hyphen and prior to this there are 2 carbon atoms. So, it goes as ethane, ethane 1,2-dioic acid. I hope with whatever IUPAC nomenclature I have taught you, you should be able to do it now. Now, let me go to the next part. I am going to start with all the organic reaction. I am going to club all the 4 chapters of organic chemistry into different parts of reaction. Now, let us start with the organic reactions. All the organic reactions present in the 4 lessons of organic chemistry, I have clubbed them into different processes. The first one being addition reaction. Some of the reaction you have already studied in class 11th. Let me also revise that first. For example, the reaction what you have already studied in class 11th, I am just writing one of the example. When I use the word addition, whatever reagent I am adding, I have to just add across the double bond or the triple bond. I have taken an alkene here. This is ethene, the common name, one of the common name. The common name of this compound is ethylene. I hope everyone remembers, ethylene is one of the gas which is used for ripening of fruits. This is ethene. When I am reacting with this double bond is going to become single bond. We all know that the valency of carbon atom is 4. So once the one of the bond is broken, I have to satisfy the valency for the carbon atom. So this 1, 2, 3, the fourth one. Now similarly the bromine also Br2. So like this it is. This is a bond. I've got a bromine atom here, I've got a bromine atom here, the bond is broken. One bromine goes to this carbon, one bromine goes to this carbon. I have to do the addition only wherever the double bond or the triple bond is there, and hence the compound goes as this. This we have already studied in class 11th. Now try to name this compound. The name of this compound, I've told you this is an halogen, haloalkane. The alkane part is ethane, so I'm writing the word here as ethane. Halo, there are 2 bromines there, so the word goes as dibromo. The position of the bromine, the first carbon atom, second, I can either name it from this first or this second, and hence it goes as 1, 2 dash dibromoethane. This is one of the tests, this also is studied in class 11th, one of the tests to distinguish between an unsaturated hydrocarbon from a saturated hydrocarbon. Bromine is dark brownish color liquid. When this is mixed with ethene, what happens? The solution turns to be colorless. This is a colorless substance you get. The brown color gets discharged and the solution turns to be colorless. Let me take the next one. I am taking once again the same compound. I am now adding here HBr. This is a diatomic molecule consisting of 2 atoms. This is also a diatomic molecule. What is the difference between these 2 diatomic molecules? When it is a diatomic molecule, this is a bond here, I have got an atom here and an atom here. Here both the atoms remains the same. So I am telling this is an example of a homodiatomic molecule. This is once again 2 atom molecule, so it is once again diatomic molecule, but since both the atoms are different, I use the term called as heterodiatomic molecule. Now in this case, addition is once again like this, CH2 single bond CH2. The HBr is going to split up as H and Br one side. So H goes here, I can write this part CH3, this part Br. So I am putting this one as Br. Now let me come to the next one. Let me take the same compound in a different alkene. I am taking this one in this. I hope you will be able to tell me the name of this compound. The name of the compound is propene. Now to this if I add HBr, I have 2 options. Double bond is here, as I have told you in the addition reaction, whatever reagent you are adding, the addition is only across the double bond. So H will come to one side, Br will come to one side. In that case, I have got 2 options. I will just write down both the option. Here something should come here something should come here, or it can be this way. Either H can go here, Br can go here, or the Br can go here, H can go here. Let me just put the H this side and the Br here, or it can be the other way also. The moment I write it like this, the compounds are different. This one goes as 2 bromopropane, this one goes as 1 bromopropane. So if this is asked in the examination, how will you find out? Which one should you write? There is always a confusion. I am telling, if this is the major product, in that case I am using, apart from HBr, I am using a word called as peroxide. The third equation you have already studied in class 11th. I hope you are able to recall it. This concept is based on the fact Markovnikov's rule. Now I am telling the first one, this is the main product. If I apply Markovnikov's rule, in this case I have to apply anti-Markovnikov's rule. I hope everyone remembers what is Markovnikov's and what is anti-Markovnikov's rule. For this, I want everyone to try to turn to page number 288. Please note it down, page number 288. Try to solve question number 10.4. I hope everyone would have noted that. Similarly, turn to page number 289, question number 10.5, the fourth part. Page number 311, question number 10.14, the 7th part and the 8th part. There is one more question. On page number 325, Question number 14.5, first part. Whatever questions are given you, whatever page number, immediately turn the pages, solve those questions. All these questions are having the applications of Markovnikov's and anti-Markovnikov's rule. Do you remember what's the other name for the anti-Markovnikov's rule? It is the peroxide effect and the Karash effect. I hope you are able to solve those questions. Let me go to the next reaction. Now let me continue with the addition reaction, some more addition reaction. Addition in carbonyl compound. I hope you remember which are the two function groups I have told you under the carbonyl compound, aldehydes and ketones. Now some of the reaction in aldehydes and ketones. In that the first part, let me start with ammonia derivative. When I write ammonia, ammonia is NH3, valency of nitrogen is 3 and this is ammonia. Ammonia derivative, I am just removing one of the hydrogen, so H2, and here in place of that H, I am going to add something, I am just putting a box. So with NH2 dash, I am just putting a box, I am just shading it. So I am just representing that ammonia derivative to be like this. Let us just take one of the example. Can you identify the functional group? This is an aldehydic group. This is ethanal. The common name of ethanal, acetaldehyde. To this, if I add hydroxylamine, as the name suggests, hydroxylamine, there should be an OH group, amine, there should be an NH2. If you club them together, I am going to get NH2OH. That NH2OH, I am writing it this way, NH2OH. Remember, in the question paper, when you get in the examination, you may not get it to be written this way. It will be written as NH2OH. For your convenience, I am writing it like this. What will be the product for this? Just remove the oxygen and the H2O, and thus the byproduct is H2O. The byproduct which is coming out, generally we write beneath the arrow mark as minus. Now just combine the structure and thus you get as CH3CH. Now C, everything has been removed here, so C is getting attached to the nitrogen. It is forming a double bond, OH. Such type of compound, this part, such type of compounds are called as oxime. Whatever is the name of the reactant, you write down the name of the reactant as it is. If you have written ethanal, then you write as ethanal oxime. If you have written acetaldehyde, one can write as acetaldehyde oxime also. Just see here, this is the main concept. Suppose I am just making this part as CH3. This part turns out to be ketone. If I give the name this one as propanone, this will be propanone oxime. If you want to write down the name, this part is the common name as acetone. This part goes as acetone oxime. I am taking the next one here. Now let us have the same, now let me take some different thing. Let us go for some ketone. I have taken this, I am taking propanone. Now this one I am reacting with hydrazine. Hydrazine is one of the compound used in the rockets as a propellant. It can be written as N2H4 like this. One of the naming reaction you may come across in the textbook, it is written N2H4. The same N2H4 I can write it this way. I am writing it for your convenience. So that what is the byproduct and how to write down the product, this part becomes easier. Now children, are you able to make out that? What is the byproduct? Just see the previous one and try to find out, remove the H2O. Just remove this H2O part. And this, join the compound. This compound name is hydrazine. I am telling, zine part becomes zone. So if this is hydrazine, this part becomes hydrazone. Whatever is the name of the reactant, just write down the reactant's name just prior to this. So this part goes as propanone hydrazone. I would have taken this as the compound, I would have taken ethanol, I would have reacted this with hydrazine, I would have got the name as ethanol hydrazone. Similarly, just now see here, remember zine part becomes zone. If I just remove one of the hydrogen here now and just substitute a ring here, now can you tell me how the name is going to get changed? Here the main base remains as hydrazine. I have just introduced the phenyl group and the name turned out to be now phenylhydrazine. Similarly here, since the word is zine here, it has to become zone. So here this part becomes propanone, phenyl. In the basic structure there is no change. I am just going to write down this part as propanone phenylhydrazine. I hope it is clear, and thus there are many other reagents. With that, if you react with any of the carbonyl compound, the name of the reactant remains as it is and there is slight change. Like for the first one, hydroxylamine turns out to be oxine, hydrazine becomes hydrazone, phenylhydrazine becomes hydrazone. You have to just remove that H2O part. Now for this, I want everyone immediately to turn to page number 365, question number 12.5. Now turn to another page, page number 379, question number 12.17, part 3. All these questions are based on this concept. You will be able to solve it. Don't get confused when you see the structure complicated. For example, in this case, suppose I draw the structure like this. Suppose I am drawing the structure like this. What is the functional group? Ketone. For ketone, the name goes as one. If I don't keep this, what is the hydrocarbon? Cyclohexane. So introduce that one part, cyclohexanone. So if I react cyclohexanone with hydroxylamine, what do I get? The name of the compound remains as it is. The name of the compound, this is cyclohexanone. I am giving you this part now because you may come across some of the question with like this cyclic structure, and here how it is going to get changed. I have got this part, double bonded NOH. So here it is cyclohexanone oxide. Cyclohexanone oxide. I hope it is clear. The same cyclohexanone I would have reacted with hydrazine, cyclohexanone hydrazone. The same compound I am reacting with phenylhydrazine, the name would have gone as cyclohexanone phenylhydrazone. I hope it is clear. Similarly, if I react an amine here, that part is going to turn out to be imine. Imines are nothing but Skiff's bases.